Sandra wanted to send something to Joe, right? So in that case, if it would have been the distance vector, it would have calculated, okay, how many hops I need to take to do this. Have you ever wondered that when you send an email to a friend, how it reaches to maybe another part of the world in a blink of a second? Well, welcome to the fascinating world of routing. Routing is a very core concept of networking, and in this video we will try to understand the basics of routing, how it works. We'll start with a real life example, then we'll move on to understand the basic workflow of routing at a high level, and then we will also learn about some protocols which you need to know in order to understand routing better. So without further ado, let's get started. So let's take a real life example. Suppose you and your friends have planned to go and attend a beach party, and there's always a friend who loves to drive in your gang, right? And most of the time he says that I know the route, no need to plug and play the map, I'll take you to the destination. So that guy took the main route and he was well on his way to reach the destination along with his friend. But all of a sudden, because that area didn't have network coverage, they realized that this whole path is under construction and there is no way they could reach to the destination on time with this route. Now, because there was no network signal, there was no Google Maps, and then they were stuck. So suddenly they saw a village guy standing next to this road guiding people who are stuck. So the guys went to this guy and asked for help, and he said that instead of taking this route, because this route is under construction, you go via a different route to the destination. And this guy helped them reach the destination on time and safely. So who was this guy? This guy in networking terms was actually playing the role of a router. So basically, routing is all about sending information, helping one system to send information from point A to point B. Routing is as simple as that. So this layman example could also be correlated with Google Maps. Suppose if the network coverage would have been there, these guys would have opened the Google Maps and the Google Map would have analyzed, okay, which particular route to take to reach the destination. So I hope this real life example made sense. Now let's understand the workflow in more detail and with a specific scenario where a person A sends an email to person B and how routing comes into picture. So let's take this step by step. Sandra wants to send an email to Joe. Now when Sandra sends an email, what happens immediately? So at step 1, the data will be assigned an IP packet. Now I am abstracting a lot of information which is not directly related to routing concept. There would be a DNS, there would be a mail server, there are too many things which happens, but in this workflow we are focusing purely on what routing would do in this scenario. So then the moment sender sends an email, that data packet will be assigned an IP header. Okay, what will happen in the IP header? The source and the destination IP address will be attached so that the data knows and the IP packet knows where to reach, right? The moment IP packet is assigned to it, it is then sent to the closest router. So which is the closest router in this particular LAN local area, because this is a local area router because it is within the home Wi-Fi of Sandra. This particular router's name is R0, for example. So once this will go to this particular router with the IP information, every router, now here comes an important concept. Every router has a routing table which it maintains. What is a routing table? A routing table is a set of addresses which a router maintains to understand that if this particular data comes to me, where it needs to go next, right? So that table has to be maintained by every router, and all these tables continuously to get synced with each other across all the routers. So that's an important concept. In R0, at R0 router, the routing table will be checked, and this routing table is very simplistic to show you the concept. So in this routing table, it has some network destination addresses and what are the routing paths which could be taken. So as the destination is 10.0, the router is intelligent enough to understand that out of route 1, route 2, route 3, 10.0 network address is going to route 2. So this should be the best path. What's the router's role? Router's role is to give you the best path possible. It might happen that you could go via route 1, route 3 or some other routers as well, but which is the best as per your request, right? So it will identify that okay, this particular network information is there, so it is highly likely that this particular destination IP would be residing somewhere in this particular network, right? So then router R0 will send this packet to router 2. Now router 2 will follow the same process. The moment that particular data packet comes and it will have the IP header, it will decapsulate and it will try to understand, okay, what are the information which I need to know. So it will again go through and check, okay, the source and the destination. So in the destination again it will do the marking, okay, this one, which is the IP, which is the network where it needs to go. So when it will traverse through its own, so R2 will traverse its own routing table, it will identify that okay, the destination is 10.0 and 10.0 is a direct connection with me. So what does it implies? It implies that router 2 could directly reach to Joe's network directly because it's a direct connection. So the moment router 2 identifies that 10.0 network is a direct network to router 2, it will then identify and send that packet to Joe's laptop. Very simplistic view. There are a lot of nuances which happens apart from this, but the idea is to tell you that what router does. So router will have its routing table, that routing table will be the guide. So I hope this makes some sense to you. Routing table, how it checks the IP header and then tries to understand which is the best path forward. Now how it does it, how router does this is based on certain protocol. So now this video is not meant for going deep into every protocol, but I will try to give you a high level overview of what kind of protocols are used in routing. And then if you want a specific video on protocol, then do let me know in the comment section, and if I get enough likes and enough responses on this one, I'll try to make a video on that as well. So before we understand the network routing protocols, we have to understand that at a high level we have two types of routing, static and dynamic. Static routing is it's very rare because in this particular routing, network administrators manages the routing tables themselves manually. It used to be the norm previously in old days, but now it's practically impossible to maintain routing tables yourself. So that used to be the static routing. Now in the world of dynamic routings, every router can talk to another router in their own language, which is basically protocol. What is a protocol? Protocol is a language in which two routers could talk to each other. So if we talk about dynamic routing, again we have two different categories: interior gateway protocols and exterior gateway protocols. What is interior gateway or exterior gateway? For that we have to understand what is an autonomous system, because interior gateway works within an autonomous system and exterior gateway works outside or within two different autonomous systems. So autonomous system is nothing but a collection of routers, and these routers are residing within a specific area. It could be your company, it could be your organization. Within that, if the routers are talking to each other, they go via interior gateway. While exterior gateway is when you are bypassing your autonomous system, your local organization network and going out. That's where you go into exterior gateway. Okay, so understand this is talking within your company. This is talking maybe between two different companies, right? So under interior gateway, we have three different set of protocol categories. One is distance vector, then there is link state, and then there is hybrid. To understand distance vector, you need to understand that in distance vector it is a very old protocol, wherein when you are sending when you send any data to the router only knows the next router to which it needs to send the information based on the distance which is getting calculated. For example, in our previous example, Sandra wanted to send something to Joe, right? So in that case, if it would have been the distance vector, it would have calculated, okay, how many hops I need to take to do this. And then it will only be talking to the neighboring router. It won't know that how that particular router will eventually send it. It will only have an idea of what is the distance and how I could reach it talking to the nearest. For example, in our real life example, suppose the guy who met us on the road didn't knew how to go to the beach, but he might knew that okay, I could take you to this far, and then there would be a person who could then further guide you how to go, right? In that case, it is distance vector. So now let's understand what is link state. So link state is opposite of distance vector. In link state, the router, the originating router, in our case it was R0, right? R0 will have all the understanding of what all routers will come into the path and how it could reach the destination, identifying the shortest path. So if we take an analogy, the guy whom we asked for the route next will have idea of all the routes which could reach us to the destination, and then that guy himself is capable enough to tell, okay, you need to go via this, and that's why it will be faster, right? Because this particular router could know all the other routers which are there and whom you need to talk to or traverse through to reach the destination. So that is link state. Hybrid is one example wherein you mix both the worlds, the best of both the worlds. So you will have the distance as well as you will have the link state together. So you will know how many hops you need to go, and then you will also know how many routers will be used in order to reach. So that for that you have protocols like EIGRP. So the last category is path vector, which comes under accelerated gateway protocol, and we have only one protocol under this, which is BGP, border gateway protocol. Now path vector is very closely linked with distance vector. So in distance vector we understood that the router just analyze the distance it need to take to reach to the destination, but in path vector the protocol will need the whole path to be shared, and then it will calculate that okay, how I will reach to the destination knowing the whole path. In here you are only talking in terms of the distance. Here it will need the whole path, how you will traverse from one autonomous system to another autonomous system. For example, in your own company, if you are trying to send a file, for example in AWS, right, on S3 bucket from your local from your local area network, in that case you will use protocols like BGP, okay, so that it could be sent. So in here path vector protocol, you will need the whole path. So yes, I think this is the overview of these protocols. There are details in specific to how each protocol work, and there could be a video around that as well. So friends, this brings us to the end of this video. If you give enough likes to this video and comment, then I would understand that you would want to know more about specific protocols, and then I can do more studies and try to make videos on that as well. So until next time guys, keep learning, keep sharing all your knowledge, and yes, keep hustling. Bye for now.